All right, let's jump right into it. Welcome to this explainer on the lifelines of the economy, the incredible and often totally hidden logistics of transport that literally keep our world spinning.
Think about the stuff you use every single day, right? The smartphone in your hand, the clothes on your back, the food in your fridge. None of it originated exactly where you're sitting. It didn't just magically teleport there. So it presents us with this massive logistical puzzle. How do we efficiently bridge the massive geographical gap between where things are made and where they're actually needed? How on earth do we conquer mountains, oceans, and vast continents to get a product right into your hands?
Well, that brings us to the fundamental domains of transport. It basically breaks our journey down into three distinct arenas: land, water, and air. Pretty much every single vehicle, every trade route, and every piece of cargo fits squarely into this framework. And, once we understand these three domains, we can totally decode this giant, intricate puzzle of global trade.
Here's our roadmap for today. We're going to cover 1. The lifelines of the economy, 2. Conquering the land, 3. The pipeline revolution, 4. Navigating the waters, 5. Taking to the skies, and finally, 6. An interconnected global village. Section 1. Lifelines of the economy and the prerequisites for growth. Let's start with a really helpful biological analogy. Think of transport networks like blood flow in the human body. The pace of a country's development depends almost entirely on the swift, efficient movement of commodities and ideas. I mean, you could have all the natural resources in the world, massive gold mines, endless fertile plains, brilliant engineers, but if you can't move those resources to a factory or a consumer, your economy is just kind of stuck. It's simple. Without motion, there's no market. Efficient transport isn't just some modern convenience. It is an absolute prerequisite for robust socioeconomic development. Moving on to Section 2, Conquering the land, specifically roads and railways. This is where the vast majority of our daily movement actually happens. If you need ultimate door-to-door flexibility, roadways are absolutely the answer. Just look at these numbers. Roads handle a staggering 85% of passenger traffic and 70% of freight traffic in countries with massive networks, like India. They're the undeniable champions of short-distance travel. And more importantly, roads solve the most notoriously difficult logistical headache, the final mile of delivery. That incredibly complex, super personalized route straight to your front door is something only a sprawling road network can actually pull off. And roads just have an incredible edge. They can negotiate much higher gradients of slopes and traverse really uneven, dissected topography, and they do it at a much lower construction cost than railways. They can snake up into the steep heights of the Himalayas or wind through rural, totally off-the-grid villages. They act as these vital, flexible feeder links connecting otherwise isolated spots to the bigger transit hubs. But wait a second. What if you need to move millions of tons of heavy bulk, like grain or iron ore, across a massive country? That's where you have to contrast the flexibility of roads with the unparalleled heavy lifting power of the railways. Roads give you freedom, for sure, but railways, they give you scale. Railways are the principal mode for large volumes of bulky materials and moving millions of passengers over long distances. Now, obviously, their initial construction cost is exponentially higher, and they demand relatively flat, forgiving terrain, but their sheer carrying capacity makes them a massive integrating force for a nation's economy.
Section 3, the pipeline revolution, and the idea of continuous flow. Let's look at a totally new arrival on the transportation map, one designed entirely for nonstop movement. Now, you might naturally think pipelines are only for liquids, right? But through the creation of something called slurry, they offer a seriously ingenious engineering solution. Slurry is basically just solid materials like raw coal or iron ore converted into a liquid state by mixing them with water. This means we can move massive amounts of heavy solids overland silently and smoothly through a pipeline, totally bypassing the need for fleets of trucks or endless cargo trains. It is literally a massive logistical cheat code. The cargo flowing inside these hidden networks is actually pretty fascinating. While the initial capital cost of laying thousands of miles of pipelines is extremely high, their day-to-day running costs are practically zero. This allows for an uninterrupted, totally weatherproof flow of water, petroleum, and natural gas straight to refineries and cities. But here's my favorite, most surprising fact. In New Zealand, milk is actually supplied through pipelines, directly from dairy farms to processing factories. Just imagine that, a brilliantly efficient, hidden lifeline moving milk right under the hills.
All right, Section 4, Navigating the Waters and Global Oceanic Routes.
So, the crucial question here is, what happens when you hit the edge of the continent and you need to move heavy freight globally without going completely bankrupt? Well, waterways are the ultimate economic solution. The physics of it are just incredibly favorable. The physical friction of water is far less than grinding against land, which makes energy costs significantly lower. I mean, it takes a fraction of the fuel to push a heavily laden cargo ship through the ocean than to pull a train of the exact same weight over land. This doesn't just make it the cheapest mode for bulky goods, it actually makes it the most eco-friendly transport mode. The carbon footprint per ton-mile of cargo on a ship is vastly lower than a truck or an airplane. Plus, there's another massive financial advantage. Oceans require absolutely no route construction. You don't have to lay miles of steel tracks or pour thousands of tons of concrete across the Atlantic. The route is already perfectly paved by nature. It simply requires deep, well-equipped port facilities at both ends to handle all that complex loading and unloading. Moving to Section 5. Taking to the skies, the fastest transportation. But what if your logistical problem isn't about moving heavy bulk freight, but an immediate need to conquer impossible, unyielding terrain where roads or ships simply cannot go? You see, landways are constantly challenged by physical geographic friction. Think landslides, massive swamps, dense forests, heavy snowfall. For instance, before the ultra-modern Atal Tunnel was built in the Himalayas, entire valleys were completely cut off from the rest of the world for 6 whole months a year due to snow. When we face difficult terrain, whether it's using mountain cable cars to scale a peak or dealing with a route that is totally impassable on foot, we have to look up. We take to the air. Air transport fundamentally brought about a connectivity revolution. Now, it is by far the most costly mode of travel, so no, you wouldn't use it to ship cheap, heavy grain. But it completely bypasses all geographic friction. Jagged mountains, blinding snowfields, vast deserts, they simply don't matter to an airplane soaring at 30,000 feet. This makes airways the absolute best choice for high-value cargo, like electronics, highly perishable goods, and, crucially, for reaching completely inaccessible areas. In places like the frozen terrains of northern Canada, air transport isn't a luxury. It's literally the only way to deliver essential supplies to isolated communities. And our final section, Section 6, the interconnected village working as a cohesive system. Bringing all these physical domains together, we really start to see how they shrink our massive world into a tightly interconnected global village. It is so critical to realize that roadways, railways, waterways, and airways aren't just competing against each other in isolation. As we can see, in a well-managed transport system, these various modes actually complement each other. They form a deeply symbiotic network. Just think about the life cycle of a single product for a second. A massive ocean freighter brings thousands of containers to a coastal port. Then, a railway carries those bulk goods hundreds of miles inland. And finally, a network of agile trucks delivers them right to your local store. They all work seamlessly together as one cohesive system. And as we transition deeper into the 21st century, the movement of physical, heavy goods is being partnered with an entirely new kind of logistics. With the rise of optic fiber cables, we're seeing the lightning-fast movement of data. We're shifting from solely transporting heavy atoms to seamlessly transporting weightless bits. We're moving ideas, billions of dollars, and crucial communication rapidly, securely, and virtually error-free across the globe, at the speed of light, shrinking the world even further. Which leaves us with a fascinating final thought to ponder. Telecommunications and modern computers have merged to form the internet, successfully conquering the friction of distance for information almost entirely. So as this digital cyberspace continues to seamlessly merge with our physical space, how will our traditional physical lifelines, our concrete roads, steel rails, and massive ships, have to adapt to keep pace with a world that demands instant delivery? It is an incredible frontier. I really hope this explainer gave you a fantastic framework for understanding the lifelines that keep our world moving.
Thanks for watching. For daily APPSC Group 2 study material and updates, please subscribe to our channel and press the bell icon.